Hello. Good evening, everyone.
Good evening, ma'am.
So,
Hello.
yeah, hello. So, we'll wait for 1 or 2 more minutes and then we'll start the session. Okay, so in the week 4, in the session, we'll be covering the relational algebra and relational calculus part. And if you have any doubt in the activity or practice assignment questions, then you can unmute yourself and ask at the end of the session, like when we are done discussing the topics. So at first, we'll be studying about relational algebra. So let me share my screen. Okay. So is my screen visible?
Yes, ma'am.
Okay. So let us begin with relational algebra. So a relational algebra is a procedural query language. It consists of six basic operators, which are just a minute, which are select, project, union, set difference, Cartesian product, and rename. And so we'll be discussing about these operators in details. So let us at first begin with the select operation. So the notation used for select operation is this is sigma, then p, and then the relation r. Here, p is the selection predicate and r is the relation. In the predicate, we use operators like and, or, not, and like just to specify the condition. Like in where clause in SQL, we specify a certain condition, right, to fetch certain data. Similar way, in this particular notation, p here we will be using like the condition according to which we want to fetch the data. So this selection operation in relational algebra performs the same as where clause in SQL. So don't get confused with it. So as you can see in this particular example, that this is a particular relation, and then when we perform this particular query, select a equals to b and d greater than 5, from this is the r relation, then we will get, so A equals to B is this one will be returned and this one will be returned and this one will be returned. Then we also have D greater than 5. So D should be greater. So this one and this one satisfies. Now since we are using the OR operator, AND operator, so the conditions, both the conditions should be satisfied. Only those tuples will be fetched. So here we can see that this particular row and this particular row will be fetched. So here, as you can see, alpha alpha 1 7 and beta beta 23 10. So this is what is selection operation. Then we have project operation. So the notation is, this is pi, and then a1 a2 are the attributes. These are the attribute names, and r is the relation. Remember that here, like it can project any number of attributes, as you can see in this particular example, that there are three attributes. So there can be any number of attributes corresponding to the relation. Okay, here project operation in relational algebra will perform as the select clause in SQL. Basically it will fetch the columns, and the select operator will give the condition, right? So yeah, so also remember one more thing. Since relations are set, so duplicate rows will be removed. As you can see in this particular example, alpha 1 are repeating, right? So the duplicate value will be eliminated, and this will be our final result. So that is project operation. Then we have union operation. You might have like gone through it when we were studying about set operations in SQL. So it performs similarly only. So R union S, it will basically return, it will fetch the attributes which appear in either or both the relations. It will fetch those tuples, sorry, not attributes. It will fetch those tuples. So there are certain criteria also to fulfill, which are that the R and S must have the same arity. R and S means the relation. So same arity means same number of attributes. Okay. And then the next one is that the data type of those attributes should be the same. So here, if you can see R and S, and we can see that, okay, the number of attributes are same. Along with that, the data type is also same. So if you perform a union operator between R and S, if you perform a union operation between R and S, what we will get? All the tuples of R and all the tuples of S. If there are any duplicate tuples, then it will the duplicates will be basically eliminated. Okay, so if you can see, alpha 1, alpha 2 and beta 1 from R are fetched, and alpha 2, since it will like be a duplicate, so only one of the copy has been like presented, and beta 3 of S has been given. So this is how a union operation works. Okay. Now we have the difference operation. So what happens in difference operation? So this is the notation R minus S. Now what happens in difference operation is that, say for example, here we are using R minus S, right? So what will happen? That it will fetch all the attributes of R, eliminating all the common tuples or all the attributes of S. Okay, so let's try to understand this with the help of an example. So here, if we perform R minus S, then if you can see that this particular attribute, or sorry, this particular tuple is the common tuple, right? So when we perform R minus S, this particular tuple will be eliminated, and we will get alpha 1 and beta 1, as you can see here. Also, one more thing, that the criteria that we applied in the union operator, which were that R and S must have the same arity, and it must be compatible, which means that the data type must be same of the attributes. So please remember that. So that is difference operation. Then we have intersection.
Ma'am, only data type or name of columns also?
No, not name of columns, the data types. The data type and the number of attributes.
Number of attributes should be same, right?
Yes, that's right. That is the arity. That's the same arity, which means that the number of attributes should be the same. Okay. Okay. So, okay. So, say for example, let's take this particular example. Don't just look at this one. Okay. So, we'll try to understand this. So, this is a relational algebra expression. So, it says that since project operator will fetch the column, right? So, we'll get a course ID of those courses where the semester is equals to fall and year equals to 2009 from the section relation, minus the course ID where semester equals to spring and year equals to 2010 from section. So what this means is that out the course ID of those courses like which which were taught in the fall of 2009. However, they were not taught in spring of 2010. So that is how a difference operator works. Now we have intersection operation. So if you can remember that intersection, as the name suggests, it will basically uh, fetch the common tuples from both the relations, right? So in this particular example, we know that alpha A and alpha A are the common tuples. So when we perform an intersection operator on both of these relations, then we will get alpha and 2. And again, those particular criteria should be fulfilled here in intersection operation as well. Uh, this is another expression for R intersection S. This is equivalent to R intersection S. Now, if you ask me how, so okay, so let us take R minus S. What will be the value of R minus S? Can anybody tell what will be the value of R minus S?
It will be the whole R except the S which is overlapping with it.
Okay, so
Like
can you tell the
alpha 2 will not be there. Alpha 1 and beta 1 will be there.
yes, that's right. Alpha 1 and beta 1 will be there. So this
Mm.
is what is R minus S. Now here what we are doing, we are again using R minus S. So R is this particular relation, right? And R minus S is this one, this particular relation. So R minus S,
So
what will it return?
alpha 2 will only be there.
Alpha 2.
Exactly. Alpha 2 will be returned because if you can see that alpha 2 is the only attribute which is not common, and these particular tuples are the tuples which are common in both the relations, right? So this is an equivalent to intersection operation. Next one is Cartesian product. So this will also be quite familiar to all of you. So this is the notation for Cartesian product. And as you all know that if we perform a cross join between two relations, then it will basically give us all the possible combinations between the two relations, right? Now since here you can see that there are no attributes with the same column name, right? So what happens there is it will basically perform it will directly like cross join everyone, like a1 to these tuple, this tuple, this tuple, this tuple, means it won't check. So since no attribute name is same, so it will basically return this particular table. So that is how Cartesian product works. Now we also have
Ma'am,
one more. Yeah.
Ma'am,
if in Cartesian product, if the resultant relation we have two same rows, will it
Okay.
keep both or one?
It will give both. If you remember from the session where we studied about joins, right? There
Yes.
it was showing that when we perform a Cartesian product or a cross join, then it will return the duplicates, right? It will give the
Yes.
duplicate attributes also. However, whenever we use natural join, it will eliminate the duplicate. But here, since we are using the Cartesian product, so it will basically give, suppose if here is also one more b, then how it will give is, it will give r dot b and s dot b. So basically, it will give, yeah, both the duplicates, basically, both
ma'am,
the common attributes. Yeah,
what is the disjoint here?
sorry,
Attributes R and S are disjoint.
this one.
Yeah.
Assume that attributes of R and Z disjoint. That means there are no common attributes. Here, if you can see, right, that the attributes are not same here, right? It is A, B and C, D, E. So that
Okay.
means it is disjoint. So this is when this will happen.
And ma'am, in Cartesian product, we can have a different number of attributes in both relation, right?
Yeah,
Won't
we
matter.
can have it. Yeah, in this particular example only you can see that, right?
Mm.
Yeah. Okay. Yeah, as I mentioned that if they are not disjoint, then renaming must be used. So when, as I said, that we will have to give r dot b and s dot b when we like get the like resultant table basically.
Okay.
Okay. So we also have one more operation named as rename operation. So what will happen in rename operation is it will allow us to rename a particular relation. So here if you can see, returns the expression E under the name X. So like we won't be using this quite that much, but yeah, this is also one of the operations. Okay. Now we will come to
Can you
the
go back to
division of,
rename?
yeah.
So here that
Mm.
what is getting renamed? Is it the relation that is supposing we have that relation R, right?
Yeah.
Is that, are we renaming that as E? Because I was not clear. What are we renaming here? I don't know if my question is
Se-
clear.
Okay.
Second
Hello.
line
Yeah.
says
Sorry. Sorry. What? Can you repeat?
I was just trying to
I lost.
understand. Here we are
Mm.
doing renaming. So what
Yeah.
are we renaming? Are we renaming the relation or the renaming the attributes?
We will be renaming the attributes.
So
If
when
you
it
can
says,
see
You mean
here.
alias name, ma'am? Alias name?
Yeah, you can say that it's like alias name only. As we use in from, then we use the table name student say as s, right? So similarly, in that way, we will be using the rename operation.
But ma'am,
but
then
we are
how are we
renaming to
getting the
what?
attributes A1 to AN?
Sorry.
Then how
At,
are we getting the attributes A1 to AN, ma'am? If we are renaming the attribute itself, because I believe this meant that it renames the expression altogether.
Hello.
Yeah.
Hello. Yeah, yeah. See here. So if you see the first expression row x of e, so if there is a relation r, so we can rename it as a relation x. So instead of in e, if there is attribute name, then we can rename it as say x. So for example, if you want to rename student as student underscore first name, right? So what you
Yeah.
can do, row operator, then that then instead of x, you can simply put student underscore first name, and inside the bracket student. So
Sir, if
inside.
I could ask you to give an example based on what ma'am just said, that the B in the previous example we had R and
Mhm.
S, wherein suppose if B is a common attribute and we want to rename it, in such a case, how do we go about doing that?
Sorry, R and S.
So
In terms
here,
of relational algebra, are you asking, right?
yeah, yes, sir.
So
So the
we have
same
this
way,
example, I mean, A, B, and C, D, E, and supposing now we have to do that renaming. So what are we doing exactly here?
Yeah, so suppose I want to fetch, say, we have the resultant tuple R cross S, right? I just want A and the R dot B. Okay, so how to fetch that, right? Using renaming. Yeah, so, so Anjana, can you write down so pi? So you can write down pi of A comma R dot B, then inside the bracket. Simply instead of row, yeah. Yeah, inside the bracket you can write. Yeah. No, no.
so in this
So
case, we took A and R dot B and then C D E. So we renamed B as R dot B. Is that
yeah, yeah, and
okay?
and one more bracket is required. So after e, so that
Yeah.
r cross, yeah.
Yeah.
So
Yeah.
after e, you can simply mention. So r is already there, right? So r into s, that we can write r cross s. Yes, that's. So we are projecting all the attributes, but only the r dot b, not the s dot b. So in this case, we
Okay.
have the 5 attribute.
Okay. Okay,
Yeah.
sir. Yeah. Got it. Thank you, sir.
Thank you. Yes, Anjana, you can continue.
so we are renaming the attributes, right? Not the relation itself.
See, as I said, can you scroll down, Anjana? So this example you understood, right now what we have discussed, right?
Okay.
Yeah, so that's how we rename the attribute. But if you want to rename the relation, you can simply use like r cross instead of r, you if you want p, so row then p, then in bracket r, so that is r will rename to s, sorry, r will rename to p. Simply you can look at below example, right? Instead of E, we are just renaming it at X, right? So E is a relation and no above one. So where we are renaming to X.
So E has been renamed to X.
In the first case,
Okay.
yeah.
No
In the
X.
second case, we are renaming the attribute. That's what Anjana explained. Okay, we can take for example few examples also.
Yeah.
Yeah, that will be better. Yes, yes, you can continue. Anjana.
Okay. So now we'll head to division operation. So just to sum up, it will basically return those tuples. See, we have two relations R and S. Okay. So it will basically return those tuples from relation R which equate with every relation that is present there in relation S. Remember, every, not one or two, but every tuple that is present in S. Okay. It is applied to two relations only. It can't be applied to more than two relations. Okay. So now we'll try to understand division operation with this particular expression. Okay. So say for example, we have R and S. This is the R relation, and we have 1, 2, say 2, 4, and again 1 and 5. And we have one more relation, that is S, and here we have SS4. Okay. So now we'll try to get the division operation of this particular of these two relations. Okay. So at first, let's get what we will get if we get the R minus S. Can anybody tell which tuples will be fetched if we use this particular expression?
1,
R
2, and
minus
1,
S.
5.
Sorry.
1, 2, and 1, 5, ma'am.
That's
1,
right.
2, 1, 5.
Exactly. 1, 2, and 1, 5. Okay. Now, when we will perform a cross joint with S, when we perform a cross joint with S, what we will get then? Uh, just a
1,
minute.
2, 4,
Okay.
1, 5, 4.
Okay, just a minute. When we perform R minus S, is this the result that we will get?
No.
Okay.
1 to 1.
Okay.
We
Exactly.
probably
Yes.
will get 1,
1,
1,
2.
right, ma'am?
Yes, that's right. Yes,
1.
that's right. Exactly. So we will get 1, 2, and 1. Now, when we perform a cross join, what we will get?
We won't get 2, right, ma'am? Would we get 2?
Yeah.
We will get, because see, 4 is in S and in relation R also it is. So that whole column will be
Okay,
definitely.
what happens when we perform a cross join? It will return all the possible combinations, right, of both the relation.
Yes,
Yes, ma'am.
Yes, well,
Yeah. So when we cross join this particular this we got, right, these many tuples we got, and now we have to cross join it with S, that is this particular relation. So what we will get? 1,
4,
4,
2, 4,
2, 4,
1,
and
4.
1, 4, right?
Ma'am, I couldn't understand your first step, ma'am. How did you get 1 to 1 in R minus S of R?
Okay, so have you gone through the difference operation? Did you
Yeah,
understand
I
the
have,
difference?
ma'am. No,
Yeah.
I basically am thinking that S is 4. So wouldn't that 2, 4
No. Look, here we are using capital R minus capital S, not small r minus small s,
okay.
right?
Okay. Yeah.
Yeah.
Yeah. Fine, ma'am. Yeah.
So you got it, right? How we
Yeah.
got
Yes, ma'am.
this?
Yes, ma'am. Yeah. Thank you.
Okay. So the result of the projection of R minus S of R in cross join S is this particular, these are the tuples that we get. Now, can anybody tell what will be the result of this particular expression? That is projection of R minus S, comma S of R. What we will get? Anyone? Just try. Anyone would like to try?
Ma'am, this means it is a Cartesian product, right?
No, it's
Comma,
not a
comma, the
partition
comma.
product. No, no,
What
no.
does the comma imply, ma'am?
Okay, say for example, we had two attributes A and B. Okay,
Yeah.
and if we give projection of A, B, and say it was A, then what we will get? We'll get A and B both, right? So
Yeah.
here R minus S is the A. You getting my point?
So sir,
Ma'am will get whole relation.
all relation are and
Exactly. Yes, that's right. So we'll get 1, 2,
Mm.
1,
Can you
and
just start from the beginning? I mean, your R's, I'm getting mixed up between your capital R and small r, and
okay, look.
and
So
maybe
the
can you use different? So your R is your capital R and capital S separate tables, or they are attributes?
the small r and the small s are the relations. The
Okay.
capital R and the capital S are the attributes of those relations. Is that fine?
Okay.
So, like, if you see this particular expression, that is projection of R minus S from the relation R. So, this is the relation R, if you can see, right? Now, what we want is we want R minus S. So, when we say R minus S, we will only get this particular tuple, these tuples, because we are performing the difference operation, right? When we perform the difference operation, it will eliminate everything that is there in the right hand side attribute. Getting my point? R minus S. Yeah.
Ma'am,
Hmm.
so when we are saying capital R minus capital S,
Yeah.
right?
Yeah.
So because in a small r table, both
Hmm.
capital R and capital S are there, right?
Yes.
And in a small s table, only
Hmm.
capital S is there. So when I'm doing
Exactly.
R minus S, so which S? Whether it belongs to small r or it belongs to
Here,
capital S? Sorry,
here,
small s.
okay. So here you can see, right? Okay, just a minute. So we have specified here that it belongs to small r.
Okay.
So by that we can say that it
Okay, so
belongs to
this
the
this
small r.
S belongs to a small r table,
Yeah, yes,
right?
that's right. Yes. Because we have specified it here, right? If it would have been S, then like here we don't have R, but otherwise, if we would have R, then here we would have used S, right? In case of small r.
So so
So
ma'am, so just I had lost the connection. So that capital S belongs to a small r table, right?
Yes, that's right.
Capital S
Yeah.
belongs to a small r table, right? So
Hmm.
in
Right.
that case, ma'am, r minus S would be, I
Huh.
think, one only. Sorry, yes, one only.
Why?
it will be 1 to 1.
Yeah. Why one only?
No, two each common, no? So I have to
so
eliminate
what
the
is
common element.
okay? I think
I
you'll
have
have
to
to
eliminate.
explain what R minus S is. How does R minus S work? I think we are getting
I
confused there.
no
Ma'am,
no
can
we
you
are
take some other
related.
example,
Could
ma'am?
you
Can
write
you
We
in
take
are
some other
different
example,
ways?
ma'am? Yeah.
Yeah,
Okay.
can you just clean it and rewrite, clean
Yes,
the
ma'am.
Yeah,
no
please.
whiteboard
Yes,
and
ma'am.
start
no
again?
no in difference operator we remove the common element, no? That is the
Okay.
point.
Okay.
Yeah, in difference we get rid of the common element, right?
Right. That's what I am also saying. So two each common element. So I will get rid of common element.
Yeah, but here we are performing like in the relation only, right? R minus S. In the relation only, we are performing R minus S.
Yes. Yes.
So
Both
we'll,
of them belong to same.
yeah, both of them belong to the same relation.
How are you performing within the relation R minus S? Isn't it between? Can you go back to that difference slide? Let's try and understand that, how that is working.
Okay, yeah.
So here you have two different relations, right?
Okay,
AB and
but
AD.
here we are performing the difference operator between the you say relations, right? However, if we would have given it A minus B, it would have given alpha, alpha, and beta. You getting my point? But since we are using R
No,
minus S,
how are you doing a difference within the relation? There are two separate columns, right? A is a separate column, B is a separate column.
And ma'am, one more problem is there. Like there is R, there is S, and there is another R minus S. So which A minus B you are doing? It's not clear.
Hello.
Yes, sir.
Hello. Yes, sir.
Yeah. So simply you can consider R minus S means only the R and the remaining attribute is say R only. So basically we are just fetching that R attribute from the relation R. So
So,
whenever they, yes.
sir, basically, anytime we have a difference, if I think of a set theory concept, right? If R as an attribute has a tuple, let's say 1 to 1, right? And then S has 2, 4, 5. So all we are saying is when we are saying R minus S, what does R attribute, capital R has that S does not have, right? So in that case, since there is nothing in common, so we are not really getting rid of anything. We are only getting R in it. Will that be a correct way to think about it?
Or if you look at that statement you just last made, R minus S is just returning R. Then why don't we just project R? Why are
No.
we
Yes, yes.
projecting R
We are
minus S?
projecting. We are projecting R only here. Only R attribute we are projecting. So whenever there is R minus S, simply we are projecting R.
But then why do we write it as R minus S? Why can't we just write project R?
So if you like, we are
If
referring
you
the
have
Cauchy
many
reference
attributes,
group.
I
So
think only
yeah,
R
Hello,
would
only
not
R
be
will be there.
working.
hello,
Yes.
uh, hello. Am I audible? Right.
Yes.
Yes, yes.
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 Yes, you are audible.
Okay, okay, okay. Just a minute. Anjana, can you stop for a moment so I
So
can share my
another
screen?
corollary will be if that original relation R has R, S, and T. In that case, would we say then R minus S minus T? If our goal is to project only the first attribute, that will be
Uh,
also another related
No, we
question.
have to see in other relation also which attribute is there. So suppose your three attributes is there in the first relation and two attributes is there. Say PQR and there is QR. So in that case, P minus QR. So only P attribute we have to project. I am writing the alternate relation. Just 1 minute.
okay, just let me take the screenshot. Okay. Is it visible to everyone, right? Hello.
Yes, sir.
Okay. So,
Yes, sir.
so R minus R division S means it will select all the means suppose let's take this is a course, right? Course table, right? Course table and R has attribute like the course ID. Fine. And this one R is the student table, right? And this will have the student ID and course ID, right? So what capital R means set of attribute, right? These are the set of attribute, and capital S means CID. This is the set of attribute available in particular S. R minus add S is not so difference operator. Here R minus is R minus S means SID, right? In this particular expression. So what is your expression? So expression is first expression collector. So
you're removing the common elements.
yeah, removing
Okay,
the
so R minus S is basically just removing the common elements between the two.
common
Not only
element,
element, I think common
common
column
attribute.
it's
Yeah, common
No,
column.
common attributes.
Common
When
Yeah,
I said
attribute.
elements, sorry, I
common
meant
no
attributes.
need to confuse. R minus S means that is the difference operation. That is the columns you need to consider.
Okay,
So
so
what?
See, that was the
you are
thing. We were all
you are
considering
removing the
difference
complete
operation.
column. Yes,
Yeah,
correct. You are
yeah.
removing the complete column.
So that is means R minus S means here. So that is pi. You have to pi here. You have to select the SID, then cross product. Then you have to select the this one means whatever is present in the S, right? Up to this is clear, right? So you get suppose here table is present A, and so let me
So let's
take.
take one example. Supposing we have
Okay.
on table A, we just drawn, right, which has
Yeah.
columns
Okay, I'm giving the example of them.
Some big. Let's take a bigger table. Let's, for
Okay.
example.
Yeah. That's
So,
will be fine.
so you have employee table, which has or student table itself
No, I
has
am
student name,
taking
first name, last
this
name.
example, so you can generalize it. So
Okay.
suppose course is, suppose S is course here, and R is a student, right?
Are you writing somewhere?
No. Here it is visible, right?
Now it's
Course,
visible. Yes.
yeah, course, and course table has the one columns, that is the CID, and this is the entry CID1 and CID2, right? And this is the student table, right? And this is S1, S2, S3, and entry is like S1, C1, C2, C1, and then
Can you
S1
also
again.
add some attributes, other attributes, so it become more clearer? Supposing student has last name, first name, course has
Yeah,
first
that's
name,
I
first
will
name.
give. First,
Yeah.
understand this part,
Let him
then
explain. Yeah,
I can
let him
generalize.
explain. Yes.
Yeah.
So up to this is clear. So suppose
Yes,
let
sir.
me
Yes,
take,
sir.
okay, suppose C1. Yeah, up to this is clear. Okay. So what is your first step? So can somebody tells the whole expression, so I can write and explain one by one. What is that expression? Pi r minus s. Let me check. Just
Pradeep, your screen is not visible.
yeah, just looking for that particular expression. Okay, got it. So fine. So this is your first step, right? So you have to select pi r minus s of r. So what is that attribute? So you have to select. Can someone tell? R minus s r. So what are the value? So these are the value, right? S1, S2, S3, S1, and S2, right? So this
Yes.
is a relational algebra. So you have to select only unique value. So that is S1, S2,
S3.
S3, right?
Yes.
And what is the value in S? So that is C1, right? Cross C1 into C2. So what is your final output of this whole expression of this expression? So you have to write S1, right?
S1
C1,
C1, S1 C2.
S1 C2.
S1 C2,
S2
S2
C1.
C1, S2
S2 C2.
C2, S3
S3 C1.
C1, S3
S3 C2.
C2. Up to this is clear, right? So now what you have to write, that is R minus S. R minus S means that is
S1
SID,
plus 3.
SID, and S means CID, right? So you have to project this two attribute from R. So that means the whole table is itself is a R minus S into S, because this is SID.
No, so now in second step, pi r minus s is becoming only s1, s2, s3, right?
Second step is this table itself is you have to minus from this whole
No, no.
expression.
Second step means the right hand side of the, within the parenthesis expression, like after minus you are writing a pi r minus
Yeah,
s comma
that
s
is
of
not
r,
a
right?
difference operation. That is
Ah, so
not a
no, no, now r minus s is nothing but s1, s2, s3 only, right? Am I correct up to this?
R1S means, yeah.
R minus s
R
is
minus
becoming
S,
s1, s2, s3
yeah.
only.
So this table itself means this whole expression you can replace with this whole table with means R. You can write directly R. So that is right. So this is for simplification. It is right like this. You can simply write R. So what is the value in the R? You can here you can see S1, C1, S2. I am writing this. This is the table content and this is the table content, right? So you have to write S1, C1, S2, C2, S3. I am writing this value because here itself it is okay. C1, okay, S1, C2, S2, C1, right? Up to this is clear, right? This is the first step. This is the second step. Then you have to, this is the final, this is the difference operator. Actual.
No, sir, can I interrupt for only fraction of second?
Yeah,
Like
sure.
this the second part, like which you have encircled pi r minus s comma s in
Yeah.
parenthesis r. You are saying
Okay.
take this as a r table. This
Yeah.
part is not getting clear because when we performed an operation pi r minus s and we got s1, s2, s3, right?
That is not an operation. Here it simply means R means set of value, set of attribute in.
No, I think only one link is missing now. Why I'm writing as r minus s? Simply I could have written as a pi r s
Yeah, you
of
can
r.
write that. Yeah, you can write that. Absolutely, you can write that. For the simplification purpose, it is written on the slide. Just you can simply replace this part with R, this whole expression.
No, because the first because in the first expression you remove the common element, and after removing the common element you perform that cross product, right? You
Yes.
perform that in first step you remove the common element. So after removing the common element, I am getting s1, s2, s3 only, right? So the moment whenever I will see pi r minus 1, I will put only s1, s2, s3. Why I will put the entire column? That point is getting clear. I think this is the only missing link for me.
Oh, okay. Let me tell you. So here R minus S means SID, right?
Yes, SID, yes.
And S means CID.
CID, correct.
Okay. Here you can see
Yes.
when you project the whole table, here you can see you have to consider both the value. Is there any duplication?
But SID in R minus S is just S1, S2, S3.
Yes.
No.
And then you are projecting that along
No.
with CID. So
Yeah, you have to project at a time, means both the time you have to consider if here one extra value C1 and C2, S1 and C1, then you can say this value is a duplicate value. You have to consider together, not one by one.
So we are considering duplicate also along with in R minus S, second step.
Okay.
SID CID combination must be unique, right?
So you know the set operation, right? If I simplify this thing is the set operation. Suppose this is the set value, right? So what I am here done, R minus S means I only return this value, right?
S1, S2, S3.
Yeah, in this. So what is your value? S1,
S2,
S2,
S3.
S3,
S3.
then S1
Yes.
and S2. But you know this is the set. Set is allow only unique value, right? So what is your final output? S1,
S1, S2, S3.
S2, S3.
S1, S3,
S3.
right?
Yes, this
In
part is
similar
clear.
manner,
Yes.
you have to write this also. So if I write this thing, okay, in similar manner, if I write this one, yeah, okay, this expression, right? So what is my output? So that is
S1, S2, S3.
S1,
S2,
C1,
S3.
S1, C1, S1, C2.
S1, C1. So this is the individual one entry in my set. Okay, this is S3, C1, S1, C2, and S2, C1. Now tell me, is there any
S2,
duplicacy
C2,
of?
sir.
Yeah,
Not
no.
C1.
S2, C1. This
So
S2,
then there is a
C1.
duplicate.
Where it is?
S2, C1, S2, C1.
S2.
Second element and fifth element. Second and fifth are becoming
Second element of fifth element. Yeah, this is my mistake. This is not allowed. So this should not be taken like this value. Now it is fine. If I
So I think
consider only this value, so you can eliminate that also fine if you consider this value also. So yeah.
Okay, Pradeep, what we can do is we can take an
No,
example.
yeah, it is fine. Here it
No,
is the
you
second
complete
value
it,
is
sir. You complete it.
S2.
You are going fine, and yes, yes.
Yeah,
Please
yeah.
complete it.
S2 and C2. Yeah. Here you can see this is S2 C2, not S1 C1. Up to this is fine. Now it is unique value. Check it.
Now it is unique.
Okay. Right. Up to this is fine. Okay. So we can consider only the R as the second, this R relation, right? This one is a R
And
relation. Okay.
and
Now there
now
is
we
a
will perform the
set.
yes,
Yeah.
yes.
Now we have to perform the set difference. So now tell me, we can cancel this one. S2, C2, we can cancel this one. S1,
S3, C1 also we
yeah,
can cancel.
yeah, and
S3, C1.
S2, C1 also we can cancel, and
Even
S3,
S3, C1.
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 So only one value we can see, S3, C1, right?
S3, C2.
S3, C2. So final output
Okay.
of this one, this whole expression, let me change up to this. Okay, so output of this one is S3, C1, or C2, right? From
Okay.
this
Yes.
result set, I have to project R minus S. R minus S means I have to project SID, right? Okay.
Yeah.
So what is the value of SID?
S3.
That is S3, right?
Yeah.
And here you have to project R minus S by SID from R. So now tell me what is that value? That is S1
And S2.
S1 and S2.
S2 and S3 also, right?
Yes, S3 also.
Okay,
Yes.
S3 also.
And then you have to apply the set difference, right?
So
And
we'll
you
get
can,
S1, S2.
so this
S1,
is our
S2.
final S1, S2. So here you can see another way.
Okay.
This S1 and this S1, S2, it present all the value of the CID, right? And S2
So,
also, this
so which you are referring?
this one, is it
So
visible?
the
Table.
original table, yes. The
Yeah,
left
yeah.
hand side table.
Okay,
Left
okay.
hand side.
This
Okay.
one. C1 here you can see C1 present, and S1 here C2 also present. For the value of S1, all the value of this S table is present, right? C1 present and C2 also present. For S2, C1 value and C2 value is present. But you can see for the S3 only C1 is present, right? So your output will be this. So the query is like that. You have to find the student ID who have enrolled in all the course available in the course table. So this is your query. Then you have to write this expression. So this will help you to write in the SQL query, right?
This expression, relational algebra.
Yeah, this is.
So that means the first one is telling us list of students, which is S1, S2, S3. Then we are subtracting any student who has not taken all the courses.
Yeah, this part will tell you not take all the courses.
Right.
After that, you subtract from the whole available on the SID. So that is for all the student. Right. I hope now it is clear.
Yeah. And then when we look at the second part, the big expression, the first part is saying what are the theoretical, let's say I have two attributes. In this case, you are talking about course ID and student ID. So if I got, let's say, S students and C courses, or let's call it M and N. So theoretically, I should see M cross N combinations in the data. But empirically, when we run it, we may not find all M N combinations. So whatever combination doesn't exist, that difference will get on the second part. That is essentially people have not taken all the courses.
So
and then
this is one way to correct interpret. Some students said already. So this is the disqualified student. This will disqualified student. Then we can, if subtract from the whole SID, we get the qualified student who took all the courses.
So sometimes it's better to work on a complement. Sometimes we can get it directly. So in this case, the example is, first we have to find out who doesn't qualify, then subtract that disqualified students to get our final answer. Yeah. Sometimes the question could be direct where we can get it directly through projection. But here we have to eliminate some elements or students who are not qualified.
So this is the way we can find the who take all the courses. I hope.
Pradeep sir.
Yeah.
Yeah, thank you for explaining it so nicely. Just one more question, last question, in fact.
Okay.
So when we are writing, pi operator subscript r minus s, then how to read it? You are saying that this is not the difference operator. So how to read it? What is this actually? When we are writing pi sub.
Let me tell you.
Are you getting my question?
Yeah,
when I'm writing
sure.
subscript r minus s, then yeah.
So one thing you have to understand. So in the pi operation, we cannot write here. We write only the projection column name. We have to project, right?
Yeah.
In the project. Right. So there is no question of the this difference operation, right?
True, so I will simply write student ID. I will simply write student ID SID. Why I will write r minus s?
No. You do not have to write. So this is not in the expression. Not. So in the pi operation, we only mentioned the column, right? Yeah, attributes. Only that.
So my point is in place of r minus s, why can't I write simply SID? Because that
you can write
ultimately.
So
you can go both ways. You can write r minus s, or you can write SID. Both will fetch the same column.
And then I'm taking the Cartesian product from course ID, right? Yes. S table.
Yeah.
I'm taking
S table.
Yeah.
So in real life, what may happen is student relation may have 5 attributes.
Yeah.
Course may have 3 attributes. So in that case, it will be very clumsy to write r minus s minus t minus u, right? Because then it makes sense to, so here it's a toy example. We have got two attributes and one attribute. So we can write whatever it is. But in real life, when we have got multiple attributes in a relation, then we have to use the most efficient notation basically. But ultimately the result will be the same.
So here you can see SID, right? SID and S name you can see. And this is the CID, right? And another is a course. Suppose this is the CID here, CID, and suppose there is one attribute more, address you can see. and this is
maybe credit in the course, how many credits it is, number of
yeah,
credits, 2 or 4,
credits.
whatever. Yeah.
So this should be subset of this one. Only when then only we can apply the R division operation, right? So whatever's attribute here present. So suppose this is the set of attribute. Capital S is a set of attribute available in the S, and capital R is the set of attribute available in smaller, right? This relation. So this should be a subset of this one. Then only we can apply the division operator, right?
So here in the example that you've given, the student and the course, it is not a subset, right? So we can't do that.
So it can't do that.
Okay.
Here it should have the credit also,
Yeah,
student. Then we can apply only the division operator.
But in a third degree normal form, you would have something unique for course. So that means before we do that, we have to, we have to work on the course minus all the elements that we don't need, right? Before we do that. So because we'll have primary key and foreign key, right? So when we are expressing this,
No, that is a different condition, right? That is a different thing. But when you apply this thing, right? This one, division operation. So generally we do not put like this. So table structure is do not like this. I'm just giving an example.
So, but if suppose the table structure is like this, then the elongated expression that we have, that we can use still, right?
Yeah, you can do that.
Even if the division is not okay, but we probably would get an answer using the big expression. I'm not sure, but I believe so.
Here you can do that. So here r minus s, what is your value? Pi r minus s. So that is you get pi r minus s means.
Apart from CID, I get all of it.
Yeah, CID and credit.
CID and credit.
Yeah.
Both will go away. Yes.
And address, right? So this is, then you have to apply your cross product
Cartesian
with
product, yeah.
Cross
Cartesian
product with
with,
Cartesian product with S.
With S.
Yeah, right.
CID and credit.
Then minus this one. This is your r minus s, and this is your s, right? So, so this is r minus s, right? Up to this r minus s, and this is your s, right? So this is means student table itself you have to subtract from here. Clear up to this part?
Yes, sir.
Yes, sir.
Then you have to project r minus s, so that you have to project SID, S name, and address, right? And then you have to subtract from this whole means. Okay. So
SID,
this,
S name, and address.
SID, S name, and address from R table, right? Now it is clear, right?
Yes, sir.
Okay, thank you. Okay, Anjana, you can continue.
So where do we use this? I mean, in
real life,
practical life, how and where will we be using this?
I gave one example, right? Student with the SID and CID, right? And the course with the CID, right? So the query is like you have to find the student ID who took all the courses that is available in the course table, right? Then you can write the division operator.
So even the IIT online degree course, the email that comes. So for example, now there are some people who have not signed up for the projects like DBMS or MLP. So they have found out the list of students who have registered for MLP project, but have not filled the Google form yet.
Yeah.
And those students are getting a targeted message that, hey, deadline is 30th September. Please fill in the form. So that is actually output of a query. Somebody in the backend is running it. All of us are, kind of tuples in the database, right? So It's a real life case much closer to home that we can think of.
Okay.
So these notations that we use, the pi and the sigma and rho and all, I mean, is it used for normal writing, or do we use it while running an SQL or something like that?
Yeah, this expression, you already got the expression R division or equivalent sum expression, right? You
Yeah.
can write in the that expression, you can write in the SQL also.
Okay, okay.
So if you can write that in the SQL, so
Yeah.
simple you
So
can.
every SQL statement can be written in relational algebra form.
Okay, sir. So the things that we were doing before, where we used to write unions and all those things, you can write it in this form as well. The queries that we were running until week 3.
Yeah, but no, you have to, if you want to fetch the data, you have to write SQL code only. This is just for, you can see, like theoretical thing.
Okay, so the way we have written that expression, that we don't put it into the PG admin
No,
or
no,
anything
no, no,
anywhere.
no, no,
Okay.
nothing.
This is kind of a shorthand way of writing it, right, sir?
Yeah, yeah.
Yes,
Okay.
yes.
This is a mathematical way of writing the query, we can say.
So it's a
Yes, yes.
relational algebra, and
Yes, yes.
there we are writing SQL. So both are different. I mean,
Yeah.
Say, yeah,
uh,
say suppose I don't know anything about the SQL, but I want some data from you. Say you are working on say database. So, but I
Yes.
know relational algebra thing. So I will write a simple query in relational algebra and I will give it to you. So your work is to convert that query in SQL and give me the data what I want.
Okay, got
Yes.
it, sir.
Yeah,
Yeah,
yeah.
fine.
Same thing for TRC and DRC.
Okay.
TRC.
Yeah,
Thank
okay.
you, sir.
Mhm.
Thank you. Anjana, over to you.
Okay, so is like division operator clear, or shall we take another example? I hope it's clear.
We can
Uh,
continue the flow, ma'am. I think where you know in the slide, so we can continue from there. Of course, the concept is clear now. After Pradeep
Actually,
sir.
whatever I was about to teach, that the same thing Pradeep taught. So like,
Okay, okay. Then we can move ahead. No?
okay,
So there is duplication now.
Then we can move ahead. Yes.
okay. So we'll head to TRC DRC then. So TRC is basically TRC DRC. So basically, we have relational calculus. So relational calculus is a type of non-procedural query language. Okay. Now, what a non-procedural? Can anybody tell what is a procedural query language? Anyone? Or the difference between procedural and non-procedural? Okay. So procedural query language basically is where to achieve a result, the procedure is given, that is as to how we can get the data, what is the procedure and what is the result. In procedural language, all these things are given. However, in non-procedural query language, by the term itself, we can tell that only the result, what we need to get, what data we need to get is specified. However, how we need to get the data, that particular uh, thing is not mentioned in a non-procedural query language.
Yes,
So,
directive query language.
sorry,
Directive query language.
directive.
Yeah, procedural and non-procedural. So I think non-procedural is directive. What professor said. No problem. I will continue. Sorry to bring that.
Okay. So, okay. So, relational calculus is a non-procedural query language, and relational algebra is a procedural query language. Now, relational calculus is basically has subdivisions which are TRC and DRC. Okay. So now we'll head with TRC. So the syntax of TRC is we say T of so here we have a tuple T and a predicate which is P of T. So based on these conditions, we'll get this tuple. So as you can see, T is the resulting tuple. P of T is known as predicate, and these are the conditions that are used to fetch T. Okay. So in the predicate, we can use the operators which are and or not. We can use these operators. However, we can also use the quantifiers, which are one of them is existential quantifier and another one is universal quantifier. So, I hope all of you are aware of it. So existential quantifier basically means, so if you can see here, by this particular expression, we mean that there exists a tuple in T in relation R such that predicate Q of T is true. If Q of T is not true, then the tuple won't be fetched. Okay, so that is how it works. Then we have universal quantifier, where for all tuples in relation R, Qt is true. So as you can see in this particular example, so P instead of T, we can take any like any letter we can take. So here instead of P, we are taking P, and then there exists S. Students is a relation, okay, and student consists of name, age, CGPA. These are the attributes of students. So what we write at first, for every, sorry, there exists S that belongs to students, then bracket, in bracket will give the condition, right? So what we want is, we want the name and age of students who has CGPA greater than 8. So we mention this particular condition, that is S dot CGPA greater than 8. Then we mention and. Now since like because we want to get P, P is the tuple, it is the resulting tuple, right? So what we want is, we need to specify P dot name equals to S dot name and P dot age equals to S dot age. So name and age are the attributes that we will be fetching, like based on this particular condition. So by that, what I mean is that it will return the name and age of those students who have a CGPA above 8. And remember, we have to use the AND operator for this particular condition, because these are very important. If we don't use these like conditions, then it will give a wrong, like it will be wrong basically. So we'll try to understand this with the help of examples also, so that it gets much more clearer to you.
Ma'am,
Yeah,
students is a table, right?
yeah, that is a
So
relation. Yeah,
so
that's right.
whether S stands for the short form of students or what? S belongs
No,
to a student.
yeah, yeah. So S here belongs to students. However, if we would have taken any other letter in the place of capital S, that would also have worked. However, here you should have taken the same like,
These are the attributes present in student table, right?
yes, 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 that's right.
Okay, like CGPA, name, and age.
Age,
Okay,
yes, that's right.
okay, okay.
Okay. So now we'll study about DRC. We'll take some examples also. Let us at first be clear about TRC and DRC. Okay. So TRC is again another non-procedural query language. In DRC, we basically focus on the attribute of a tuple. If you can see here in TRC, we will be focusing on the tuples of the like relation. However, here in DRC, we will be focused on the domain, that you can say as the attribute of the relation. Okay. So if you can see here, this is the syntax of a DRC. So x1, x2 till xn represent domain variables. So we want to fetch, these are the variables which we want to fetch. And then we have a predicate condition, represents a formula similar to that of the predicate calculus. So this is a particular example. So remember one thing, that okay, we will be giving domain names. So A, B, C, D. Okay. Remember one thing, that the order of the domain should be the same throughout. Okay. So say again, we want to find out the name and age of those students whose marks is greater than 75. Okay. So what we will do, name and age is A and B. So we took A, B, then we use this, and then there for some A, B, C, D, then in bracket what we write down as A, B, C, D. Here in this here, what we can take is, we can take B, C, D, or we can simply take B, D also, or C, D also, anything will work. Then here we take A, B, C, D belongs to students. We have to mention that, right? Belongs to student, and we will give the predicate. We will give the condition, that is C should be greater than 75. Then, so this particular expression basically specifies that it returns the name and age of students having marks above 75. Okay, now we'll try to understand these with the help of examples. Okay. So these are the two tables that we have, students and activity. So we need to find out the relational algebra, TRC and DRC. Okay. So write down the relational algebra TRC and DRC expressions, which will return the name of students whose age is greater than 25 or who are enrolled in maths. Would anybody like to volunteer for the relational algebra? How we can find out the relational algebra? Anyone? We want the name of students whose age is greater than 25 or who are enrolled in maths. So for relational algebra, would anybody like to volunteer?
Ma'am.
Yeah.
So, ma'am, first we will do the project name.
Oh, project name.
Project
Yes.
name, and then we will select sigma age
Age.
greater than 25
Yes.
or
Okay.
uh, who are enrolled in maths, right? So sigma subject
Yes.
equals
Sorry.
to sigma.
Okay, you don't need to use sigma again. Okay, once you have used
Okay.
sigma, you can use as many
Okay.
conditions you want.
Okay.
Okay.
So student, sorry, subject equals to
Subject
40 max
equals to maths.
and bracket
Okay.
students.
Yes. So that is how relational algebra works. I hope it is clear to all.
Yes.
Okay. Now, would anybody like to volunteer for TRC? Or shall I go? Okay. So, if you remember, okay. So if you remember, the syntax of TRC was such T of PT. Here, PT was the predicate and T was the resulting tuple, right? So, okay. So again, we take T, then we take we have since so we have to fetch tuples from the students table only, right? So we'll take for there exists S. Okay, just a minute. There exists S that belongs to students. Then in the bracket we take. So what is the condition? It says that the age should be greater than 25. So age greater than 25 and subject equals to maths.
Ma'am, it will be or.
Okay, sorry. Yeah, very good. So it will be or, since we are specifying that or. Okay. Or, and then now since we want to take out the name, so what we will do is T dot name equals to
S dot name.
S dot name. So is this the correct TRC?
Yes, ma'am.
Okay. Yeah. So this is the correct TRC. So anybody has any doubt? Okay. So we'd move to DRC. So now in DRC, so the syntax of DRC was such that x1, x, right? This was the resulting tuple and we had
In this last one, why did we put that T name equal to S name? And
because we want to fetch the name of students, right? So for fetching, we have to take this particular, sorry. So for fetching the name, we have to use this particular condition. Otherwise, it won't fetch. So the tuple so this is the resulting tuple only, right? So the resulting tuple should have the name that is equal to the name attribute from the students table.
But if we have a
But
duplicate
we are
names,
doing
sir,
intersection there, no? Because you're saying and T name equal to S name. So why that and condition is coming?
Because the sorry, because the tuple, the resulting tuple should have the name like which are present in the students table. It should be there. We can't use the or operator in this case. It should be there. Otherwise, what will it fetch?
Nothing.
Yeah, it will fetch nothing, right? So to fetch something, we need to have this.
So
That
you
is,
are
there is a
making the
join.
tuple.
We need to equate that one to S name.
Sorry?
We need to equate the T name to S name.
Yes.
But anyway, the first where conditions are built based on this totals table, no?
This is not a procedural language, right? This is a non-procedural language.
Ma'am,
So yeah.
one confusion here, ma'am. It's really same for the T named and equal to S dot name, ma'am.
Hmm.
So, what does the S dot name represent here, ma'am? Student, right?
Yeah,
Yeah.
the S dot name will present
What about
represents
T
the
dot name?
name. Yeah, yeah. Please go ahead.
Yeah. What about the T dot name? What it represent, ma'am?
These are the names that we will be fetching. Remember, T is the resulting tuple, right?
Yeah. So we are fetching from the students table only, right? Data.
Yes. The name should be same.
Yeah. So we
Yeah.
are not making any join with any other table, right? So we
No,
in
no,
this
no, no,
table,
no.
yeah,
If we would have made join, so if you remember that what we need to do is we need to equate the common attributes, right? So say for example, if we were like using students as well as activity, then we should have used this one more condition, that is, here you can see that name is the common attribute, right? So in that case, say for example, we took for some A belongs to activity, then we should have taken S dot name equals to A dot name, because we have to perform a join, right, in
yeah,
between
yeah.
both the tables.
That's true, ma'am. But in the same table only, ma'am.
Hmm.
Okay. So we don't need to pass the name condition here. If we just pass age greater than 25 and
Okay,
subject
say for
to that,
example, we are not using this particular, we are not
yeah.
using this condition. We are only using this condition. What will it fetch?
Where's
Will
the
it
age
fetch
is great?
just the name?
Sorry.
Okay,
See,
we
I
want,
think
the
the
question says
confusion
that
is
we,
how do so the last condition only tells us which column to bring,
fetch,
because
right?
it
That's
doesn't
right.
make sense, because ideally it should be somewhere outside, no, which columns are required, because you're putting it as part of the predicate, which
Yeah.
means you're putting it as a condition somehow.
Correct. That's a
No, no.
understanding is, yeah.
Yeah. Hello. So this is a non-procedural query language. So we'll only get the information like what data we have to find out, right? So in case of relational algebra, we know like how to find out data by using the project operation.
But
So
why it has to come with the and operator then, sir?
yes, I'm
You
explaining.
understand?
So there are different conventional. So in some of the reference book, you can see at the beginning only they will mention t dot name, then vertical slash, then you will write the whole predicate thing. Okay. But in some of the reference book, they will mention after they will not use that form. They will mention in the predicate only that and t dot name equals to s dot name. So whatever the attribute you want to fetch, they will mention like this. Say suppose if you want to fetch marks also, so they will mention t dot marks equals to s dot marks. Okay, these are the different convention using the different reference book.
So
So
supposing I have on 2 3 columns, then I'll have to first put and t dot name equal to s name and t
And
dot
yes,
age
yes,
equal
yes,
to marks and
that thing we have to do. Yeah,
So in this case, for the question asked, I think DRC will be straightforward. TRC will be a little more complicated, right? So depending on the question, for this one looks like DRC will be more straightforward.
yeah. DRC is easier than TRC.
Yeah.
Even in join also. Yeah. But whatever you want to fetch that particular attribute, you have to mention like this: t dot name equals to s dot name. You can in some of the reference book, and you can also find out that t dot name is mentioned before the vertical slash. That is also fine.
So
But
there are
what you
different, sorry to interrupt. So there are different ways to write TRC, right? If you have,
different
if you would have
conventional, yeah.
written T dot name, then also it would be correct.
Yeah, it
You don't
doesn't
have
need
to
to be
write that.
correct. Yeah, you don't have to write that last condition.
Last
You
one.
can simply
Okay.
mention t dot name. That's it.
Okay.
As we are projecting pi name, simply you can mention t dot name. But the what are the convention we are following for this course is this only. Okay, we're not following that thing. I think in the tutorial I have explained this thing. You can watch the tutorial also. There is tutorial on TRC. So in that I have mentioned that we have this is the alternate form of writing the TRC query, but we will follow this thing only.
Okay. This thing which you have written.
Yeah, this thing
Okay.
only.
Okay.
Yes,
Yes,
Sanjana.
Sanjay.
Yeah.
Okay. So DRC, this is clear, right? Okay. So someone said that DRC would be straightforward. So can you like unmute and tell how we can do it? So say we are considering A, B, C, and D for TRC. DRC, sorry. So yeah. Anybody would like to volunteer? Okay, no issues. So it says that we need to return. Yeah,
Yeah, ma'am.
yeah, okay.
So in
Hmm.
DRC, we will go with um, A attribute. Sorry,
Oh,
A
yeah,
attribute.
yeah, that's right. Okay. A,
Does that
okay.
A, B, C, D belongs to student?
Okay, just a minute. So we'll take B,
Uh,
C, D. We need to take all for this right. There
I think we
exists.
have to take all.
Sorry.
Yeah, we have to take all. No, not in
Yeah,
this. Um,
So we have
we
to
need
write
to
A
take
also, no? We have to.
A. We are fetching right. So we can take A. We can, it's the same. We can take either or. Like if we take A,
okay,
B, C, D, it's fine. If we take B, C, D, it's also fine. If we take C, D, it's also fine.
okay. So B, C, D belongs to students.
Okay. Okay. Then we need to take what we need to take. We
Yeah,
need to take all the attributes
yeah. A, B, C, D
that belongs to.
students.
Okay. Then
Um, and C
yeah.
greater than
C.
25. Sorry,
Are
age.
you
No?
sure it
B,
will
B,
be?
B. B,
Yeah,
sorry,
that's
B.
right. B should be greater than 25
Or um,
or
D equals to max.
D equals to maths. Yeah, that's right. So this is the correct TRC. Okay, so we'll head to
Ma'am,
some more. Yeah,
ma'am, no, one small doubt. I'm sorry,
yeah, yeah,
sorry to
yeah,
intervene
yeah. No
again.
issues.
Like,
Yeah.
like in DRC, we
Hmm.
try to fetch the name of the feature, right?
Yeah. Name of the
Like
student.
column name, column name.
Yeah,
In
yeah, yeah.
DRC,
Hmm.
we try to fetch a name of features like column names, right?
Right, right.
But here once again we are going to get names of students only, na?
Yeah,
Ma'am, can you please break down each and every section, ma'am, here? Can you please
Yes,
explain?
because I was thinking that based on the query, based on the question, we will have to provide the name of the column. Like there are four columns here: name, age, marks, and subject, right?
hmm,
But
hmm.
by writing through this way, we are going to get the name of the students like David and those three people who are eligible in this case, Anand and Sean, right?
Yeah,
Then what is the difference between TRC and DRC? Because both of them are serving the same purpose. No? Because in TRC also we are going to
yeah.
get
Both of
names of students.
okay. Both of them have the same purpose only, just they are different representations. You can use either TRC or DRC. Like these are just two different like divisions of relational calculus.
Ma'am,
You can use
representation is
either.
different
Okay.
and syntax also different.
No, no. I
Yeah,
was
syntax
thinking
is
when we say
different.
domain. No, I was thinking that when we are talking about domain relational calculus, it means I will
Hmm.
get the name of columns, and in
Yeah,
DRC, I will get
hmm.
the name of records, right? Which all
Tuple.
records satisfy this condition. Tuple, yeah,
Hmm. Yeah,
record means tuple. Which all tuple satisfy this condition. That was
yeah.
my understanding.
Okay.
I thought that through DRC, I will get the name of features, means name of columns, and through TRC, I will get only a tuple. But you are saying
Okay.
that both of them are serving the same purpose.
Yeah, both of them are serving the same purpose. Okay. So in DRC, you're right. We will be getting the column. However, according based on the condition, it will fetch only those tuples in that particular column. Are you getting my point? Like, okay, so okay,
Yeah, yes,
somebody
yes.
wanted me to break down. Okay, so I'll just say, so here at first we have A. So by that, what we mean that we will be fetching the name column. Okay, then we use the vertical slash. Then there exists BCD or ABCD. Then we take the bracket, and here remember one thing: we need to specify all the attributes, all the domains in a particular relation. Okay, belongs to students. Then what we will do, we will specify the conditions that are given. So, and B greater than 25 or D equals to maths. So B here we have mentioned that B is equal to age and D is equals to subject. So that is why we are using B and D and we are
Ma'am,
using the or
ma'am, what
yeah.
about this? Ma'am, I understood this part. Okay, just
Okay.
first part only. I just missed this thing. So when you say this, yeah, that this B C D. So what does
Okay.
it represent, ma'am? How does it represent, ma'am? Yeah, I mean, what is the point
Yeah.
of yeah this
So
relation? Yeah.
like it's like there exists BCD or ABCD, and then this is the condition. So that is why we are using this.
Condition is okay. So you mean select A. A is nothing but a name, right?
Yeah, yeah.
Uh, and B, C, D. What does it mean, like, ma'am? You
These
said
are the attributes of the student table, right?
yeah, I
These
understand.
are the
Yeah,
other attributes apart from
yeah.
that. These are
Other
the other
attributes.
attributes apart from that. Yes.
Huh.
So do we need to mention
What are the
all
other?
the attributes, whatever is in the table in here in this place?
You can mention all the attributes also. You can mention some of them also. I have just taken BCD. Here you can take ABCD also, CD also. But B and D must be there because we are applying the condition on B and D, right? We are
Okay.
like the
Okay.
condition
Okay.
is that age is greater than 25 and
Yeah.
subject should be who are or subject should be maths.
But
So since we, yeah,
C we are not using, ma'am, in the condition, right?
yeah, so you can take B and D only. That would also be okay.
So
Like
will it
if you
appear? So once we run the output, so we will be getting only a name column only, right? In the
name
output.
column based on the condition.
Yeah,
That
yeah,
is,
that's true.
yeah,
That's true.
yeah,
That's true.
yeah, yeah,
So,
yeah.
so
We
here
will only be
C,
getting the name
yeah.
column.
So
That's right.
whatever condition I'm putting in that the criteria, okay,
Yeah.
those
Hmm.
column must present under the exist clause,
Yes.
right?
Very important.
Yeah,
Yes.
that is the thing. That is the main intention of this thing, right?
Yes,
Okay.
that's right.
Then inside that you need to put
Hmm.
all the columns of the table,
Yes.
correct? Like
Belongs to
in this table
student.
only you have to put this thing, right? And
Yes.
then have to put the condition.
Yes.
Correct?
Remember the order should be the same. Okay. Like ABCD, you cannot write it as BACD or something else. Remember
Oh,
the
is it so?
order should be, yeah.
Okay.
The order should be the same. Okay.
Okay. So and if
Yeah.
I need to select multiple columns, so I just need to give A comma B, right? In the tuple.
Yeah.
In the
Yeah.
first.
Yeah. Hmm.
Okay. All right.
In the
All right.
first, yeah. We'll understand like there are examples which have like more than one tuple, there you'll understand. More than one attribute, sorry.
Uh,
Okay.
Ma'am, what is the name of this angular bracket here? How to pronounce it? Like A we have written within the angular bracket, na?
You
And
can
even A B
say
C
for
D
the
we have
angular
written within.
bracket only.
Okay, okay, no problem.
Yeah.
I thought there is
It does
another
not
name
refer,
also.
yeah. Yeah, it's just the
Okay, okay,
syntax.
okay, got it, ma'am. Got it.
Also,
Okay.
Ma'am,
ma'am, should we
when we
always
must
rename the rows as the columns as
Yes.
ABCD and then do it?
No,
Or
you can use it as
XYZ
according,
also.
yeah, XYZ,
no, ma'am.
PQRST.
Yeah, can I directly use those names itself, the attribute names, name, age, or I mean, we don't use it generally like that.
Yeah,
Because
you
then
can.
here I have to say somewhere, right? The name is A and the age is B and such things.
Okay, so if you use a name, age, mark, subject, what will happen is it will be too long. Just
Yeah,
imagine here we will write name, then
yeah,
there exists age, subject, then here we will be writing name, age, mark, subject, then here again. So it will get complex, right? So this
yeah.
is just like we are using kind of the shortcut, right? We
So
are
there is
renaming the
somewhere
attribute.
that we equate both of them, right?
Yeah, yeah.
Yeah.
We just have to be sure that the order is correct.
Okay, okay, ma'am.
Yeah.
So in this case, if the question is, in
Hmm.
addition to getting a student's name,
Yeah.
let's also get marks, which is
Okay.
column
Okay.
C.
So okay,
So in
just a
the
minute. Yeah.
DRC, it will be easy, right? We can just do A comma C. But in case of TRC, I had to add a new condition. So this is where, adding attribute is very easy in DRC, but TRC, we have to add those extra things.
Yeah, so in this particular example, we will be fetching two attributes. Okay.
Okay, okay.
Yeah. So would anybody like to go for relational algebra? Like what? So we need to fetch the name of students along with the sports. So sports is a attribute from the activity table whose age is less than 25 and who have scored more than 75 marks. Okay. So for relational algebra, would anybody like to shoot?
Yes, ma'am.
Ma'am,
Projection name is
project name and
Name
sports,
and
comma
sports.
sports,
Yeah.
and select
Select.
age
Hmm.
less than 25
Less than 25.
and
Hmm.
marks greater than 75
Marks greater than 75.
from the relation students.
Huh? Sorry? Hello?
The students.
Students?
Yeah. Yeah, students.
Only from students?
Cross
Students,
activity.
activity.
Cross activity.
Sorry, activity. Cross
Not
activity.
and operator here.
Students, natural join
Okay.
activity.
Yeah, natural join. Sorry.
Yeah. Okay. Excuse me for the handwriting. I'm really sorry. Okay.
No
So okay. So for TRC, I hope by now some of you it might have been clear for you. So let's see. Anybody would like to try for TRC?
First one is clear. T given.
Sorry.
So in this
Curly
previous
bracket
one,
T, curly bracket T.
Okay.
T
Hmm.
exist S thing, right?
Yeah.
Okay. An element of student.
That's right.
Okay. Here we have to put the condition. I think, right?
We are using the activity relation also. Remember that. So
Yeah. Then student cross join shall be used here.
no.
It will only be a comma, right, ma'am?
No, we don't even need to use comma.
Comma, is it? Okay.
We can directly use it. Say A.
Okay. Exist.
There exists.
Yeah, there exists A. Yeah. Then activity. Okay. Yeah.
Okay. Okay.
Go ahead.
S dot name equal to A dot name.
Age greater than 25.
Okay,
Yeah,
one by one.
yeah,
So,
S dot age. Yeah, S dot age. I think so.
Less than
S dot
25.
Yeah,
less
greater
than 25.
And
yeah, and marks. There is a marks.
dot
Yeah,
marks.
S dot. Yeah.
Okay.
And
Okay. One thing. S dot is not required. Okay. You can simply write it as age. Age
Because
less
it's
than.
unique. Yeah, it's unique.
Yeah,
uniquely
it's unique.
Yeah.
But if you write S
Yeah.
dot also,
Okay. For better, yeah, we'll use it as S dot age only.
yeah.
S dot age.
25. Okay.
And
And
Yeah.
yeah, and
And
S dot marks
S dot marks
greater than
greater than
75.
75.
greater than 75. Okay.
Then the column we have to select, right? The column whatever we want to display there.
Yes, that's right.
Yeah.
Okay.
And operator.
Okay.
T dot name
T
equal
dot
to
name
S
equal
dot name.
Okay. T dot name equals to S
S
dot name. Yeah.
Then join condition we have to put, ma'am, from I think, right?
Okay. We also need to find out the sports.
yeah.
And
Okay.
I think,
T dot sports.
T dot sports.
S.
yeah.
A dot sports.
Yes. A dot
A dot
sports. Okay.
Sports.
A dot sports. Okay. Then,
And
is there
join
any
condition.
other condition? Yes.
Join.
Very good.
Yeah,
Yeah,
cross join,
that's
ma'am.
right.
Yeah.
So what it will be?
Yeah, S dot whatever. Yeah, S cross. Yeah, I mean S cross.
S dot name equal to A dot name.
A dot name.
Yes. Very good. That's right.
Ma'am, why S
So,
dot name equal to A dot name?
because we have to perform a join condition, right? Otherwise, how will we join these two relations?
Oh, okay. Is
Yeah.
this an,
So,
this
previous
will be a
one,
natural join, right?
so in
yes, that's right.
relation,
We
This
will.
will be a
Yeah.
natural join, right?
Yeah. That's
Okay.
right.
so in the relational algebra, we have not given that join condition, right? We have just
Here
given a
it is.
Cartesian product, right?
No,
Cross
it's a
is a
natural
Cartesian.
join.
It's an inner
It's a
join.
natural join.
Natural join.
Okay.
This is a
Students, natural
symbol
join.
of a natural join. Is it okay? Okay. So we'll head with DRC. I guess I've taken all the space. So I'll just remove it. Okay. So for DRC, anybody? Okay. So for better readability, we'll just rename it as A, B, C, D, and E, F, G, and H. Okay. Now, anyone?
So what do you want to display, ma'am? Name and sport site.
Yes, that's right.
So the
A
columns we want to
comma
display
A comma
and
Yeah.
A and E.
A
Ma'am.
A,
A E.
yes.
Okay.
A,
U F F.
A,
Exist. Exist.
yeah.
Okay.
A
Here
and
we have
F.
to put the No. Okay. Yeah. Okay.
Sports.
Sports. Yeah.
Sports
Sorry.
is F.
Yeah. Sorry. I see the E. Okay. Now we have to see the columns we are putting in the search condition. They must exist. That is the must
Yeah.
condition. So age, what is the column for age? I think name also, ma'am. Name also must exist. I think so. A and B and F also, and marks. Yes, A
Okay,
B C
one
A B
minute.
C F M.
Okay, just a minute. Okay. So, like at first, we have to take the condition for the student table and then for the activity. So, right now, let us just take it for the student table. When we will be taking it for the student table, we will specify all the conditions that we have just for the students table. Okay. And if we have any more condition for the activity table, we will specify it later. So, right now, just consider that we have the students table. So, what will be like according to it? Please tell me.
Yeah, A B
B,
C
C.
C also, ma'am.
Yeah.
Yeah.
Okay. Then,
Then okay, age condition. Yeah, all the columns from the A table.
hmm,
Okay. Then we have to put a condition over there. I don't
yeah.
have. Yeah, so I think student dot, yeah. Uh, okay. I mean, what is the age?
B less than
Yeah,
25,
yes,
ma'am.
B.
Yes.
B less than 25
B greater than
Yes.
25
and
or less
C
than
greater
25.
than 75.
Correct.
Yes. Perfect. Okay. Now we have fulfilled all the conditions given for the student. Now we need to perform a join also. So what we need to perform, like, okay. So now we need to take the in this way only we need to take the attributes from the activity relation. So it will be okay. Can you try in the
Uh,
similar manner?
F, ma'am. Yeah, double.
C and sorry, E and F.
It's not C. Sorry, E. Yeah. Okay.
E and F.
E, F.
Come on. Yeah, that's it.
Okay. Then E, F, G, and H.
H. Yeah.
It belongs to activity. Then there are no conditions for activity, right?
Right.
All we need to find. So now we need to perform the join operation. How we will do
Join
that is we will take it as A equals to E, because if you can see A is name and E is name. So we need to
Right.
specify that A equals to E.
That's it.
Then
Yeah.
can't we write A
So
dot name equal to E dot name?
yeah, you can do that also, but that will be long, right? You can simply write it as A equals to E. If you take A dot n, then you'll have to take it for the entire, like, no, A dot n actually it's not required. You
A
can
dot
simply
name.
A dot name.
Yeah.
A and A dot name is the same thing, right?
A itself is name actually.
Yeah, exactly. Hmm.
Name dot students equal to name dot activity.
Sorry? Hello? Am I audible?
Yes, yes, ma'am.
Okay.
Ma'am, thank
Okay.
you for this. This was very good actually. It cleared up a lot of things.
Okay. So I have one assignment for you all. So this is another question. So I'd request all of you to maybe take a screenshot and practice it at your home, practice it after the session and check whether you are able to solve it or not. If you are having any problems, you can post it on the discourse and we'll try to solve it.
An announcement has been come.
Okay, we will
Announcement for this
post it
question
on the
has come.
discourse. Sorry, we'll post it on Classroom. Is it okay?
Piyush sir has also posted.
Yeah, okay. Okay, Piyush sir has posted it. Yeah. So this will be the.
What is the class code?
Okay, we'll share the link. Just a minute.
Okay.
Yeah. So I hope TRC and DRC are by now at least somewhat clear. Yeah, so the classroom link has been shared by Piyush sir.
Returns. So as additional units of a variable input are combined with a fixed input, after some point the additional output starts to diminish.
Somebody's watching a video.
So do we have a Kumbhak related interpretation?
Okay. Yeah, sorry. Okay, so yeah, TRC and DRC are quite clear to all of you by now, right? I hope you will be able to solve the assignment that is given to you. Okay, so now if you have any doubts, you can go ahead. I'll stop presenting. Yeah.
And so today we covered relational algebra, relational calculus, TRC and DRC, right?
Yes, remaining part is ER diagram, so we'll be covering in the next session. But
Yeah.
before that, please watch the tutorials. Okay, there are 3 tutorials, I guess, on the ERs. No, 2 tutorials are there.
So
So
for
please,
first two videos, there are two tutorials, right? One is
yeah,
the division operator and second is TRC.
TRC, and 2 more tutorials are there. One on the case
Okay,
study
one
on
on
ER
the
diagram and ER
ER
diagram
diagram.
representation. Yeah. So please watch those tutorial before coming to the live session. So it will be helpful
Okay,
for you.
Can you explain division operator?
Sir, I have a doubt in activity question.
Yes, yes. Subindu, yeah, go ahead.
Activity
Yeah. Which,
4.2, question 3.
okay. Let me share my screen. Okay. Yeah. So this question, right?
Yes, sir, this one. Sir, I couldn't understand how it says that it is a natural join between employee and department tables
Okay.
because we have given some conditions that the department is manufacturing and such things.
So so see, we have given e dot id equal to e dot id.
Yeah.
So it will no print the natural join between employee and department.
So it's only based on that condition that we are saying that it is a natural join, right? Because there are few other conditions we are not considering those.
So let employee and department
Yeah.
to relation. The
So suppose
relation.
if I didn't mention that condition, then it will become a Cartesian product, na?
Yeah, that is
Yeah.
true, sir. But
Yeah.
like I was looking for things which have the other conditions mentioned as well, like D dot name equal to manufacturing.
No,
And again, M dot name and E dot name is also a natural join kind of thing.
no,
But there
that
was
is not a
nothing
natural
which,
join. M
yeah,
dot name is generally we are fetching the name from
details of
the
name.
employee table. Yeah,
Yeah,
that's it.
yeah.
So we're
So
applying the
it's
condition, name is manufacturing, and we are fetching the employee name. That's it.
okay. So only with this EID, DID
Hmm.
is with when we are saying that it is a natural join, right, sir?
Natural join, yes.
And we
If we
just
didn't
discard
mention,
this.
then yeah,
Yeah. Okay. Okay,
then it
sir.
is
So if
Cartesian
it's
product.
okay. Because it will return the names of employees working in all departments except manufacturing was not also not working. So I was confused which option to select because I mean I got confused with that manufacturing thing, sir.
That's just the attribute, like a condition we're applying.
Okay,
Yeah.
okay,
Same
okay,
case in
fine.
DRC also, like the example just now we discussed A equal to E, right? So if
Yeah,
we skip that A equal to E, then a Cartesian product will be there in those case, in that
okay,
case.
okay, fine, sir. Fine.
Any
Okay.
other question?
Thank you, sir.
Okay.
Can you explain division operation?
We have explained division operation. You can watch the YouTube video.
Question 8, sir.
Okay, just the last part, like the projection r minus s comma s. What exactly that means?
Uh, which part? Okay.
Question
The
8, sir.
the
Sir.
division operations last part. But I'm not like I could not figure out the notation.
So yeah. So we have we have discussed in the previous means just now we have discussed the division operation. You can watch the tutorial.
Okay.
You can watch the video in YouTube. We have just discussed in detail way. Pradeep has discussed, so you can just watch. Hello.
Yes, sir.
Okay.
Okay.
So any other doubt?
The question 8.
Which question 8?
4.2.
Okay, 4.2, question number 8. Okay. share my screen. Yeah. So choose the correct expression which are the equivalent to the relation algebra expression shown below. So x
Yes.
divided by y, right? Where x is a b and y equal to b, right? So we can see that if you watch if you had watched the division operation tutorial, so sir has explained in very good way. So t shall, the register r shall belongs to x, or all q belongs to y, rb equal to qb, and ta belongs to ta equal to ra. So this will be the, and if you see in the domain relation calculus, this will be the uh, or
But sir, what is this R dot RB equals to QB implies implication, sir? This symbol, arrow symbol.
yeah. So see the which q belongs to y, this symbol, right?
No, no, I'm talking about this. RB equals to QB arrow, TA equals to RA.
Yeah, this belongs to.
That is
What
because
is?
we are returning only A, Manan.
Yeah.
We are
Sorry?
returning only A, so we write that implies TA equal to RA.
Yeah. And this is the equivalent to domain relation calculus. So you can watch also the tutorial we have given,
Okay,
division
okay.
operation
On division operator.
and tuple relation calculus.
TRC and division.
Yeah.
Okay,
So you can watch.
okay.
Okay. Any question other than any? So if you have none of any other question, we can bind up the session. Thank you everyone. Okay.
Bye.
Yeah.
Thank you, sir.
Yeah, thanks.